Hello friends, welcome to online course. First order differential equation and its application. Week number 3, applications involving first order differential equations. I am Professor Shivaji S. Pawar. So in week 3, today's lecture number is 3, that is applications with Fourier law of heat conduction for circular pipe. So we will take some problems on circular pipe using Fourier law of heat conduction. So first, heat flow in which some basic principles are there. So basic principles involving in conduction of heat are, first one is, we know that generally heat flows from higher temperature to lower temperature, that is hot to cold. Then second principle of heat flow is the quantity of heat in a body is proportional to mass, temperature and specific heat. And third most important principle of heat flow is, that is Fourier law of heat conduction. So for solving problems we have to use this Fourier's law of heat conduction. So Fourier law of heat conduction states that the rate of heat flow across an area is proportional to the area and to the rate of change of temperature with respect to its distance normal to the area. Means Fourier law of heat conduction states that the rate of flow across an area is proportional to the area and to the rate of change of temperature with respect to its distance normal to the area. Means if we take suppose Q calorie per second be the constant quantity of heat flowing radially through surface of pipe, then using Fourier law of heat conduction we can write Q is proportional to area into temperature gradient, that is Q is equal to thermal conductivity into area into temperature gradient. Okay, so in mathematical form how we write this, Q is equal to minus Ka dt by dx, where A is the area of that circular pipe, area of lateral surface of circular pipe, dt by dx is temperature gradient, and K is thermal conductivity, or K is a constant of proportionality, depends upon the material of the body, is called as thermal conductivity. So here negative sign is attached because as distance increases, distance means distance x is increases, then temperature T is decreases. So this is the Fourier law of heat conduction. Means for solving problems we have to use Fourier law of heat conduction, that is Q is equal to minus Ka into dt by dx. Means we have to use this one, that is Q is equal to minus Ka into dt by dx. Okay, now in next slide one problem is given. So problem number 1 is a steam pipe 20 centimeter in diameter is protected with a covering 6 centimeter thick, for which the coefficient of thermal conductivity is K equal to 0.0003 calorie per centimeter in steady state. Find the heat lost per hour through a meter length of the pipe if the inner surface of the pipe is at 200 degrees centigrade and outer surface of the covering is at 30 degrees centigrade. So how we solve this problem? Here in problem given that one pipe is given and 20 centimeter diameter of that pipe is given at 20 centimeter, is protected with a covering 6 centimeter thick. Means suppose this is one pipe is given, okay, and diameter of this pipe is 20 centimeter. So what is the radius of this pipe? Suppose radius of this pipe is x centimeter, so radius is 10 centimeter. Okay, and this pipe has covering is given in problem. Suppose this is the covering of this pipe. So covering, the thickness is 6 centimeter. This thickness is 6 centimeter. This is given in problem, and suppose this is our given pipe. Okay, now thermal conductivity K is given in problem, that is K equal to 0.003 calorie per centimeter in steady state. Question A, find the heat lost per hour through a meter length of the pipe if the inner surface is of the pipe is inner temperature of the pipe is 200 degrees centigrade and outer temperature of the covering is 30 degrees centigrade. मीन्स हेयर कंडीशन इज, लिसन केयरफुली, देखो यहाँ पर क्या दिया है, ये जो डिस्टेंस है सेंटर से यहाँ तक का डिस्टेंस ये कितना हो गया 16 सेंटीमीटर. ओके, एंड फ्रॉम दिस सेंटर टू दिस इनर रेडियस कितनी है 10 सेंटीमीटर. मीन्स इफ यू एज्यूम सपोज x be the radius of the pipe, then when x is equal to 10 centimeter, only this is important, when x is equal to 10 centimeter, temperature T is given at 200 degree centigrade and outer surface is kept at 30 degree centigrade. Means when x is equal to 16 centimeter, then temperature T is given at 30 degree centigrade. आई थिंक अभी इससे आपको कंडीशन तो समझ में आई होगी. फॉर सॉल्विंग दिस प्रॉब्लम वी हैव टू यूज Fourier law of heat conduction, and for using that we want these values. When x is equal to 10 centimeter, temperature T is 200 degree. मीन्स जब इसकी रेडियस जो थी 10 सेंटीमीटर, एट दैट टाइम टेम्परेचर ऑफ इनर सरफेस इज 200 डिग्री सेंटीग्रेड एंड थिकनेस इज 6 सेंटीमीटर. सो distance 10 centimeter plus 6 means when x is equal to this 16 centimeter, then temperature given a 30 degree centigrade. So using this we have to find heat lost per hour through a meter length of the pipe. Okay, so now we will start solution. यहाँ तक तो आपको समझ में आया होगा कंडीशन क्या लेना है. अभी एक्चुअल Fourier law of heat conduction क्या है वो देखेंगे हम फर्स्ट. So for solving this problem we have to use Fourier law of heat conduction. Okay, so by the Fourier law of heat conduction we can write Q is equal to minus Ka into dt by dx, where Q is be the constant quantity of heat flowing out radially through a surface of the pipe having radius x centimeter and length 1 centimeter. Then how we write area of that pipe? Means then the area of lateral surface means belt is equal to क्या आएगा, area of lateral surface एरिया मिलेगा हमें A is equal to 2 pi x into L. L is the length, but length suppose 1 centimeter है, so area is equal to 2 pi x. Means we have to take area equal to 2 pi x. So using this, how we write next step? Next step is Q is equal to minus K into 2 pi x dt by dx. Means area की वैल्यू पुट की यहाँ पर हमने 2 pi x. Okay, now how we solve this differential equation? If we use here variable separable form, so dt is equal to, or this minus dt is equal to q अपॉन 2 पाई k इंटू डी एक्स अपॉन एक्स. मीन्स क्या किया यहाँ पर वेरिएबल सेपरेट किए. अब देखो हमें ये डिफरेंशियल इक्वेशन सॉल्व करना है, इसका इंटीग्रेशन लिया तो वो क्या मिलेगा हमें, माइनस टी इज इक्वल टू क्यू अपॉन 2 पाई के इंटू लॉग एक्स प्लस सी, ऐसा इंटीग्रेशन मिलेगा. नाउ यूजिंग गिवन कंडीशंस क्या है, अभी मैंने एक्सप्लेन की. व्हेन एक्स इज इक्वल टू 10 सेंटीमीटर, temperature T is 200 degree centigrade, and when x is equal to 16 centimeter, temperature T is 30 degree centigrade. So using this, if we integrate that equation, then we get this step. Means देखो यहाँ पर स्टेप डायरेक्टली दिए, तो वो स्टेप क्या थी, Q अपॉन 2 पाई के. ओके, Q अपॉन 2 पाई के इंटू इंटीग्रेशन ऑफ डी एक्स अपॉन एक्स आएगा log x. ओके, एंड x कैसे वेरी हो रहा है, 10 to 16 इज इक्वल टू माइनस डी टी था, सो माइनस इंटू इंटीग्रेशन ऑफ t वेरीज फ्रॉम 200 टू 30 इंटू डी टी। देखो इसको यदि सॉल्व किया तो हमें क्या मिलेगा, यहाँ पर q अपॉन 2 पाई के मीन्स दिस अपर लिमिट इज log 16 माइनस log 10 मीन्स दिस इज इक्वल टू दिस माइनस साइन एज इट इज हियर, डी टी का इंटीग्रेशन मिलेगा t, ओके, एंड t का लिमिट क्या है 200 टू 30, यहाँ पर पुट किया तो 30 माइनस 200 आफ्टर सिंप्लीफिकेशन दिस इज इक्वल टू 170। ओके, अब हमें हीट लॉस फाइंड करना है, तो हीट लॉस के लिए हमें हीट चाहिए, तो नेक्स्ट स्टेप क्या आएगी, नेक्स्ट स्टेप इज यस, इससे Q लिखना है हमें, तो Q इक्वल टू क्या मिलेगा 170 इंटू 2 पाई के अपॉन log of 1.6, log of 1.6 using log a minus log b is log of a by b, that is log of 16 by 10, log of 16 by 10 is log of 1.6. So after simplification, here 170 into 2 is 340 and the value of pi is 3.14 into thermal conductivity is given in problem, that is K equal to 0.003 upon log of 1.6. After calculation we get this 0.68144 कैलोरी पर सेकंड। ये क्या मिला हमें, अमाउंट ऑफ हीट। ओके, अब हमें क्या फाइंड करना है, हीट लॉस्ट। सो रिक्वायर्ड हीट लॉस्ट इज इक्वल टू क्या आएगा, ये देखो क्वेश्चन में क्या था, वी हैव टू फाइंड हीट लॉस्ट पर मीटर थ्रू ए मीन्स what was our question, our question was 1 minute. So our question was find the heat lost per meter through a heat lost per hour through a meter length of pipe. Per hour means 1 hour is equal to 360 seconds. So 60 multiplied by 60 and 1 meter is equal to 100 centimeters. जो heat आई 0.68144, so multiply it by 100 into 60 into 60. So final answer is 245,318.95 calorie. Okay, so this is the first problem. Second problem is same here. A long hollow pipe has an inner diameter of 10 centimeter and outer diameter of 20 centimeter. The inner surface is kept at 200 degrees centigrade and outer surface is at 50 degrees centigrade. The thermal conductivity is 0.12. How much heat is lost per minute from a portion of the pipe 20 meter long? From a portion of the pipe 20 meter long. This is given in problem. It's same as the last problem. For solving this we have to use Fourier law of heat conduction. So one pipe is given, okay, and inner diameter of that pipe is 10 centimeter. Means suppose this is the given pipe, so inner diameter is 10 centimeter, so radius is 5 centimeter and outer diameter is 20 centimeter, means it has some thickness here. outer diameter means यहाँ से यहाँ तक, ये क्या हो गई, रेडियस हो गई। ये डायमीटर टोटल 20 सेंटीमीटर है, तो ये डिस्टेंस हो गया 10 सेंटीमीटर। ओके, inner surface is kept at 200 degree centigrade. This is our pipe, say inner surface is kept at 200 degree centigrade and outer surface is 50 degree centigrade. Okay, thermal conductivity K is given as 0.12. how much heat lost per minute, per minute पूछा है यहाँ पर, from a portion of the pipe 20 meter long. So we have to convert that 20 meter in centimeter and minute in second. Okay, 1 minute is second. How we write that? So what is given in problem, when x is equal to 5 centimeter, x is equal to 5 centimeter, temperature T is given at 200 degree centigrade, and when x is equal to 10 centimeter, temperature T is given 50 degree centigrade. So using this condition we have to solve this problem with the help of Fourier law of heat conduction. Okay, now using Fourier law of heat conduction, we can write q is equal to minus ka into dt by dx, where q is again constant quantity of heat flowing out radially through a surface of the pipe having radius x centimeter and length 1 centimeter. Then we can write area A is equal to again 2 pi x. Okay, so q is equal to minus k into 2 pi x dt by dx. So using variable separable form, this can be written as q upon 2 pi k into dx upon x is equal to minus dt. Okay, if we integrate this equation 1, then we get t is equal to माइनस क्यू अपॉन 2 पाई के इंटू लॉग एक्स प्लस सी. देखो यहाँ पर मैंने पहले इंटीग्रेशन लिया, जैसे लास्ट प्रॉब्लम में इंटीग्रेशन नहीं लिया था, लिमिट पुट किया था. Here without definite integral also we can solve such type of problems. Now what is given in problem, मैंने पहले explain किया, when x is equal to 5 centimeter, temperature T is given है 200 degree centigrade, and when x is equal to 10 centimeter, temperature T is given है 50 degree centigrade. So if you put here, then we get first equation 200 is equal to minus q upon 2 pi k into log 5 plus c, and second one is 50 is equal to minus q upon 2 pi k into log 10 plus c. Now how we eliminate here constant of integration? If we take subtraction of equation 3 and 4, okay, then we will get 200 minus 50, that is 150, is equal to q upon 2 pi k. if we take common, ब्रैकेट में रहेगा log 10 minus log 5, and log 10 minus log 5 is log of 10 by 5, that is log 2. Okay, so using this we can write q is equal to 150 multiplied by 2 pi k upon log 2, and after simplification this is 163 calorie per second. Now we have to find heat lost. Okay, so heat lost per minute through 20 meter length of pipe, this is given in problem, can be written as 60 multiplied by 2000 q, 20 meter per minute. 1 minute is equal to 60 second, and 20 meter is equal to 2000 centimeter into q. The value of q is 163. So after simplification we get here answer 1956000 calorie. So this is the heat lost per minute through 20 meter length of pipe. So this is one application of conduction of heat, that is heat flow using Fourier law of heat conduction. This is most important application in first order ordinary differential equation. In next lecture we will take one more application, that is orthogonal trajectories, means how to find orthogonal trajectory with the help of first order differential equation. That we will see in next lecture. Okay, so thank you.